Let's work on another example of the limits. Here we have this example. Limit x is approaching to infinity, x times sine pi by x. If I try to plug in x approaches to infinity times sine pi by infinity becomes sine of 0. So that is sine 0. So this is an indeterminate form of infinity times 0 type. It's an indeterminate form, but to apply L'Hopital's rule, we need to manipulate it a little bit and rewrite it. So I'm not applying L'Hopital's rule yet. I wrote it as, let's see, sine pi by x divided by this x. I am writing it here, 1 by x. Do you guys see it's the same thing? I didn't really do anything. Now, if I try plugging in infinity, the numerator is sine pi by infinity is 0, sine 0 is 0, and the denominator is 1 by infinity 0. So now it became 0 by 0 format, so we can apply L'Hopital's rule. Let's do that. Limit x is approaching to infinity. Derivative of the numerator, what will be that? Cosine of pi by x times derivative of inside negative pi by x square using the chain rule. Derivative of the denominator is negative 1 by x square, so only 1 is there. And if you notice, 1 can cancel and x square can cancel. So we simplify what we have here left. Cosine pi by x, there is a pi left, I can write it inside. And denominator, there's just 1. Now if I try to plug in infinity, that will be cosine pi by infinity. Pi by infinity basically is 0. Pi times cosine 0. Cosine 0 is 1. So the answer should be pi. Okay. Please remember, I'm not really plugging infinity. We are just saying as x approaches to infinity, this approaches to cosine pi by infinity. So pi by infinity here, remember, whenever we have 1 over infinity, that should be equal to 0. Okay. So that is your example of using L'Hopital's rule when the indeterminate form is of infinity times 0. Let's try one more of this kind. This is a limit question. If I plug in 0, sine 0 is 0 times cosecant 0 is undefined, basically 1 by 0 is infinity, right? So this is a 0 times infinity format. So I'm going to first try to simplify it somehow, manipulate. Cosecant can be written as the reciprocal of sine. So this actually is in this format. Now when I try to put in 0, this is sine 0, 0 by 0. It's an indeterminate form. So I should be able to apply L'Hopital's rule to this. So limit x approaching to 0. L'Hopital's rule says differentiate the numerator. So that would be cosine 5x times 5. And differentiate the denominator. That will be cosine 3x times 3. So we have is limit x approaches to 0, 5 cosine 5x divided by 3 cosine 3x. If we try to put in 0 in there, cosine 0 by 3 cosine 0. Cosine 0 is 1. Cosine 0 is 1. The answer should be 5 by 3. Let's look at a different kind of indeterminate form. Limit x is approaching to infinity, x the power 1 by x. If I try to plug in x approaches to infinity, power 1 by infinity is 0. So this indeterminate form here is infinity power 0. Whenever we have indeterminate form of exponent kind, the first step, whatever the function is, we're going to take log of that. Okay. And when you take log, the power property says this power can come up the front because of the power property of the log. Okay, so instead of finding the original limit, I'm going to try to find this limit when I take the log. Now let's see what if I put in infinity, what happens. Log of infinity is infinity divided by x is infinity. So this is an infinity by infinity indeterminate form. So I should be able to apply L'Hopital's rule to that. Limit x approaches to infinity. L'Hopital's rule says find the derivative of the numerator, which is 1 by x, divided by the derivative of the denominator, which is 1. So what we get is limit x approaches to infinity of 1 by x. What will that be? That's 1 by infinity, and that should be 0. So we are able to find the limit of the log function. Now, our goal was to find the limit of this function. That's not log. It's a different function, right? But how do we get rid of log? The inverse function of log is exponential. So what I'm going to answer, limit x approaches to infinity of this function, how will this be different from 0 is by taking off the log. How do you take off the log? Inverse of log function is exponential. So e power 0, that would be 1. So our actual question, this answer should be 1. Okay. Don't answer 0. If you answer 0, that would be wrong because we took log. So the original questions have to be changed back to exponential like this. Okay. Let's do one more example of that kind. Let's see if this is limit x approaching to 0 from right side, some function raised to power cotangent x. If I plug in 0, 4 times 0 is 0 plus 1 is 1. Power cotangent 0 should be infinity. So cotangent 0 is cosine 0 by sine 0. So that's infinity. So this is an indeterminate form. I said if an exponential kind of indeterminate form is there, whatever the function's limit you need to find, take log of that. When you take log, the power comes down. This looks like cotangent x time natural log of 4x plus 1. Okay. Now, so instead of finding the original limit, we are going to try to find the limit of cotangent x times this. I think I can write cotangent in the denominator because cotangent is the reciprocal of tangent. Let's try to put in 0. What happens? Log of 0 plus 1, log 1 is 0 divided by tangent 0 is 0. So this, when I plug in 0, it just becomes 0 by 0 indeterminate form. So I can apply L'Hopital's rule. Let's do that. Limit x approaching to 0 from right side. Derivative of the numerator. What's that? 1 by 4x plus 1 times derivative of inside is 4. In the denominator, the derivative of tangent is secant square x. So let's try to write that down. It's 4 by 4x plus 1 times secant square x. Limit x is approaching to 0 from right side. Now if I try to plug in 0, 4 by 0 plus 1, secant square 0. So 4 by 1 times secant square 0 is 1. That should be just 4. Okay, so we did find that limit. But what limit did we find? We found the limit of this function, which is simplified as this. But our goal was to find limit of this function This new function came by taking the log of it. So the limit of the original function, which we actually needed to find, should be, how do you get rid of log? By taking the exponent. So the answer should be e to the power 4.